we're going to talk about the terms conjunction and disjunction, all right, and then we're going to solve these combined inequalities as either a conjunction or disjunction. This, again, a simple application. I told you guys last time of this. This is more common, God bless you. This is more common than just simple inequalities. You might see something written this way, where a radius of, say, a soccer ball or a baseball has to be within a certain threshold. You would say the radius has to be within, like, I don't know, 9.05 inches to 8.95 inches, okay? So you have some sort of a limitation or constraint on the problem or on the setup, so that if it's within this solution, meaning R is above 8.95 but below 9.05, it's considered to be like acceptable, okay? Versus something that would be outside of that range would be rejected from the assembly line or whatever it may be. Thanks, Will. Okay? All right, so let's look at a few things. Let's talk about conjunction. Conjunction. Paul?
The statement x is greater than a and x is greater than b.
Less than
b is called conjunction and can be written as a is less than x, which is less than b. It is read as x is greater than a and less than b. All the sentences that make up the statement are true.
All right, so in this case, and correct that grammar, in this case, remember that even though you see less than symbols here, right? See A is less than B is less than X, which is less than B right here. You wouldn't read it the way you see it that way. Again, if you read it this way, it would say A is less than X, which is less than B. A simpler way to say it is that X is greater than A by reading it this way. Remember how I talked about reading backwards? So start in the middle, read it backwards. X is clearly bigger than A. That's what this symbol means here. God bless you. That's what this symbol means. X is greater than A, but in this direction it means that X is also less than B. So it's within some range of values, okay? If A is 2 and B is 10, X is clearly between 2 and 10. Not including 2 and 10, because here I just have a less than symbol. I don't have a less than or equal to symbol in this case. Okay, remember, the equal to symbol is the shaded in circle. How about a disjunction? Go ahead.
The statement x is greater than a or x is less than b is called disjunction. At least one of the sentences is true.
All right, and that's all that we know for this part. In the first part, for a conjunction, both of those are true. Both of those statements are true. For a disjunction, at least one of them is true. They could both be true, actually. Okay, and usually we forget that other scenario, but we'll see that today. All right, so when you have a conjunction, I don't know what's up with the internet today. So let's take a look at this first example here. When you see a conjunction or you see a compound inequality, what I want you to do is treat it as if it's two different entities. Think about that middle statement as applying to both the right and the left-hand side. So separate it for a moment. Okay, again, this is a conjunction when you have multiple inequality signs in one sentence. So let's write it like this. -2 less than or equal to negative x plus 3 and negative x plus 3 less than 4. Again, that's what this is really saying. That's how you would physically write it. You would say that that middle term is greater than or equal to -2, that's on the left, and it's also less than 4, shown on the right. Now solve these like you would solve any equation. Again, solve these like you would solve any given equation, and you'll just get two results, and that'll give us a range of possible values. So I'm going to just go ahead quickly and solve these. Please remember, you need to flip signs twice in this problem, actually. Because in both cases, we're going to end up dividing by -1. Okay, we're going to end up dividing by -1 there once we get negative x as our second to last statement here and here. Now, to me, that's the easy part so far. You've split up the middle into two and statements and solved them separately. It's putting it back together that can sometimes confuse people. Now, please don't try to memorize. Just read it to yourself. Like, literally read it. If I were to read this statement on the left, how would I read this mathematically? Please don't read it the way you see it. Read it the way that we've been talking about it. How would you read this now?
5 is greater than or equal to x.
Okay, so how would you read it the other way now, as we were saying?
X is less than or equal to 5.
Alright, so x is less than or equal to 5. That's our starting point, right? So it's numbers that are less than or equal to 5. So already on a number line, I'm thinking about this. Please draw a 5 here, and draw a closed-in circle at 5, and start shading this way. Okay? That's that first statement on the left-hand side. He's absolutely right. X is less than or equal to 5. I colored in my circle. I shaded to the left because it's less than or equal to 5. What about on the right side over here? How would I put that on the number line? How would I put this on the number line? Imagine it's the same, exact same way we've done it in the last section.
-1, open circle.
All right, so at -1, you might put an open circle here and shade which way?
To the right.
To the right, because x is greater than -1. X is greater than -1. So that's the situation we've got. Agreed? And when I shade to the right, it means it really goes on forever. Like this arrow that I just ended up here, it really goes up much further. It continues on forever and ever this way. Just like this arrow really continues forever this way. Okay, so that's really what it looks like if I just exaggerate it a little bit, just to show that it continues on in both directions forever. Now, when you hear the word and, both of those statements are true. That's what and is saying. Or the other one, we were talking about the disjunction, it's one or the other are true, but they both have to be true. X is less than or equal to 5, and x is greater than -1. Well, what numbers hold true to that statement? How can I make a simplified number line from this number line that I've got here? What values are in my solution set as a result?
Anywhere between -0.99 and 5.
Yeah, anywhere between, very good, -999, etc., because it's not including that, and +5. Anything in between. So what you do is you look for the overlap. Just literally look at your number lines. Where do they overlap? They overlap here to here. So that's your solution set. So I would visually or mentally do this. Put a dashed line here in my mind and a dashed line here. That's the overlap region in between there. So my real solution looks like this, as Kelly mentioned. From -1, not including -1, all the way up to 5. Okay, that's my solution set for this problem. And that makes it a lot easier to write in solution set form once I've graphed it. So I graph the two statements individually on the same number line, and when it's an and statement, I look for the overlap of those two graphs, and that overlap is indeed from -1, not including -1, to 5, including 5. The last step is how do I write this as a solution set? Before I get to that, Paul, you had a question?
Yeah, I just want to know how exactly you got from the starting question, how you split it up to those two.
Okay, no problem. So when you see an and statement, or when you see what's called a compound inequality with two inequality signs in the same sentence, you break up the middle term into both sides. So you think about it like this. Ready? Think about this as one of your statements always, and then think about this, if I can get that, there we go, as your other statement. Okay, because that's literally, what this is saying at the top is it's saying -2 is less than or equal to -x plus 3. Then when you see another thing come after, it means and -x plus 3 is less than 4. So the fact that you see a continued statement, meaning another inequality sign, indicates the word and, where you repeat the middle term there. Okay, that's why I gave that very simple scenario in the beginning with the radius of the basketball. When you see this, right? Let me read what this means. This means that the 8.95 is less than the radius, or the radius is bigger than that, and the radius is less than 9.05. It's falling within that range somewhere. So if I were to write this statement down, I would break this up like this. I would say 8.95 less than r, and r less than 9.05. And that's how I would visually see that. I would see that, the radius of the ball is in between that range, so it's bigger than one number, but it's less than the other number. And that's what that's saying right there at the end. And that's what we do here, okay? We carry that down, but with variables now, all variables. All right, the last step. So we solve those equations separately. We graph them together on one number line. We draw one number line to represent them, and then we write it in solution set form. How do I write this in solution set form, Charles?
X equals the set of real numbers greater than -1 and less than or equal to 5.
Good. How would I write that with inequality statements or inequality symbols?
-1 is less than X, which is less than or equal to 5.
Very good. Okay, -1 less than X less than or equal to -5. Let's quickly go over where that comes from. The -1 is like your left endpoint on the number line. The 5 is the right endpoint on the number line. Where there's a closed-in circle, you see a less than or equal to symbol. Where there's an open circle, you simply see a less than symbol, indicating that -1 is not in the solution set. The solution set is every number bigger than -1, but also less than or equal to +5. Okay? Use your number line, the overlap of the number lines, to write out your solution set every time. It will help you a lot. Okay? Let's look at another. So, in this problem, what do you see already? It's an OR statement, just because of the way it's set up. And OR statements are always going to be written in two separate statements. No, I shouldn't say always. There are exceptions. But traditionally, you'll see them written as two separate statements, whereas an AND, you'll see as one compound inequality. So go ahead and solve this separately, please. And go ahead and graph on a number line. Solve them. Go ahead. Solve them each individually and graph them together on one number line. This should be quick, right, to solve this? Just subtracting simple numbers. Did we all get to this line? Yeah? Just by solving them individually? How would I graph this on a number line? What would it look like, Luca?
So you have the line, number line, -3 and equals 6.
Good.
You have the open circle and the -3 and a 6, so the air is going out.
Good. Bless you. Shading outward. And if I read those, how do I know? Well, C is less than -3. Less than means to the left of -3. Or C is greater than 6. That means to the right of 6. So this is a disjunction. Traditionally, disjunctions are going to go opposing ways. But you'll see some that don't, actually. Some that can overlap. One might run this way and then run overlapping at the top. But conjunctions always run in opposite directions, so they're overlapping. Okay, so how do I write a solution set for this one? It's really no different than the statement that's kind of boxed in there. Okay? C is less than -3, or C is greater than 6. All right, Kelly.
In my old school, we did like a different way. We
Sure.
would like -3 is less than C, which is greater than 6.
But that's not true. You can't. That's actually incorrect. Simply because a number can't be less than -3 and greater than 6. So if you write it as one statement, it assumes that those two things are both true. Remember, these are not both true. Only one or the other is true. So I wouldn't write it that way because it's not actually true. You follow what Kelly was saying there? If you write it as one line, it assumes that both statements are indeed true. That's how we wrote the last one. But here, one or the other is true. So I would write them, unless it was maybe something a little bit different than what you just said, but based on what you said, I would not write it that way. I would write it this way. Okay, because this is definitely true. If you write them as one line, it can never happen. There's no number that's bigger than 6 that's also less than -3. Okay? All right, let's look at the third example. So here you have an AND statement, okay, that's broken into two separate parts. Let's go through this, solving these separately, remember. So I would divide by that -1 just to start, right? It makes it a lot easier. Giving you k minus 1 is, instead of greater than, less than -4. And over here, 1 minus k is greater than -4. Again, I would start by dividing by the negative on the outside of the parentheses in both scenarios. Then I would go ahead and solve. This one is interesting. Answer is really interesting. Think about it for a second. They're both less than in the end. It says k is less than -3 and k is less than 5. What does that mean? What does that mean? If it's less than -3 and it's less than 5, how could it be both cases?
So then just basically k is less than -3
Why?
because it's an and, so they're both true.
They both have to be true.
Yeah.
So when I graph this, Charles, it's more obvious, right? Because now, look, that's the graph of k is less than -3. And the graph of k is less than 5 is up here. Well, remember with an AND statement, we look for the overlap of the graphs. Remember we looked at that first example, we saw where the graphs overlap? Well, Charles is absolutely right. Where do they overlap here? They overlap from everything less than -3. The range between -3 and 5, that part really doesn't matter because only one of those statements is true. But with an AND statement, they are both true. The only place where they're both true is to the left of -3. It's where you have the double line. So it turns out that our solution set is actually just this statement right here by itself. The other statement is extraneous or does not affect the problem really. Okay, for it to be in both of those cases, it pretty much just has to be in the left case. Okay, so this is what the number line would look like. You really only need this portion right here. That's it. And your solution set would be k is less than -3. Does that make sense, even though it's a little bit different? So it's still a conjunction. You don't have two things that are coming together with one another anymore. Now it's just a question of where is the overlap in the statement. It makes it a little bit easier to see that the overlap is everything less than -3. So always look for that double line and then draw one line there and whatever the statement would read. Easy so far? How are we doing? Can we go on to the next one quickly? All right. What should I do for example 4? On the left-hand side, it's pretty easy to solve. What should I do on the right-hand side to make this easy to solve? Just I threw this one in there just to see if our number sense.
Right-hand side, just move all the decimal points over to the right one.
Yeah, multiply everything by 10, right? On the right-hand side, just to move stuff over. On the left-hand side, we'll solve this. We'll subtract the 1 to get this statement. Divide by 2. All right, that's the left-hand side. But the right-hand side here, let's write this as, multiply this entire thing by 10 to make it 1f plus 5 greater than or equal to 0, or f is greater than or equal to -5. So here's my statement. This is what we've got right now. It's an OR statement. Okay, it's an OR statement. It went off again? Really? So on a number line, here's what they look like, right? F less than -5 looks like this. Right? That's what f less than -5 looks like. What about f greater than or equal to negative 5? What does that look like? What does that look like, Samin?
The point would be filled in, go to the right.
Yeah, closed in circle going to the right. So it's either everything to the left, not including negative 5, or everything to the right, including negative 5. So what's the answer to this problem? It could be everything to the left or everything to the right. All real numbers. Okay? Because you see here, we're looking at the fact that it could be this way or it could be that way. That's including every number pretty much. Not pretty much, but it exactly is. So we'd say that f is in the set of all real numbers. Okay? F is in the set of all real numbers. This again means in the set of. This symbol just means real numbers. By the way, a capital Z instead of an R means the set of integers. Fun fact, in case you ever see that. Okay, a capital Z is the set of integers. This is the set of real numbers. And the last. Okay, we've got an AND statement here. We've got an AND statement, so we're going to look for some overlap again. So we'll add 7 to both sides, getting x is greater than 11. And subtracting 2, x is less than 2. X greater than 11 and x less than 2. Something funky about this one. What's the deal here, Luca?
No solution.
There's no solution. Why not?
There's no numbers that are both greater than 11 and less than 2.
That's exactly right. There's no number that's bigger than 11 and also less than 2. If this were an OR statement, we could graph this, right? If it were an OR statement, we could find, x is greater than 11 or it's less than 2. That's possible. It could be one or the other. But you cannot have both of these. And how can you prove that? Simply doing this. Less than 2 looks like that. Greater than 11 looks like that. Well, that's clearly an OR statement like we've been talking about, but this is an AND statement. Is there any overlap of those two graphs? There's no overlap whatsoever. Thus, there is indeed no solution to this problem. Okay, there is no solution. Because remember, for an AND statement, we're looking for an overlap. We're looking for an overlap. So if you want to put an empty set or the null set, that's fine. Okay, or no solution. Any of those three is fine. So remember, for an AND statement, both criteria need to be met. It has to be this and this. For an OR statement, one or the other is sufficient. Okay? Pretty easy? What do you guys think? You're solving like you're solving equations, remembering to flip the inequality if it's negative. After that, you're looking at the graph. If it's an AND statement, you're looking for the overlap. If it's for an OR statement, they're going to go opposite directions most likely. You come up with one overall solution set based on one overall number line. Section is mainly from 2.2, you'll see here. And then I put 2 review problems up from section 1.9. Those are those word problems you guys worked on.